For my lesson, I decided to talk about constructing a circle based on a triangle. This will be done using only a straight edge and a compass, no protractor to measure the angles, but it will be accurate as a result. I chose to do this activity because my students actually really enjoy making the constructions. It really interests them that all the circles can be inscribed and circumscribed about any type of triangle, literally any type, no matter what. And that's not the case with a lot of polygons, which we talk about in class. Technology use, I used three different things. I used the geometry toolbox, which is like this really cool thing. I'm like obsessed with it. Where you can like use an online compass, an online protractor, straight edge. You can make lines, like you can do all cool stuff. So it's great if a student doesn't have access to a compass at home because they can use it on the computer. Zaption is also this really cool website, and that is you go into like a video and you can edit it so that it asks the students questions during the video. And Zaption does that, which is pretty cool. And then Screencast-O-Matic, which I'm actually using now. Sorry you can't see the whole thing, but it's a tool that videotapes a computer screen, and it records the audio and visual of the user. So right now you're seeing my screen and you're seeing me. And I use that for the videos that we'll see later on. So the standard I addressed, construct the inscribed and circumscribed triangles of a circle, and prove properties of angles for a quadrilateral inscribed in a circle. I'm not doing the second part, proving properties of angles for a quadrilateral inscribed in a circle, because when we hit this lesson, we'll have done that in a previous lesson. So the essential questions that I wrote for my lesson: how can I draw a circle inscribed in a triangle using only a straight edge and a compass? How can I draw a circle circumscribed about a triangle using only a straight edge and a compass? And can I do this with all triangles? So my objectives are stated in my concept paragraph. In this lesson, students will learn how to inscribe a circle and a triangle using only a straight edge and a compass, and how to use the same materials to circumscribe a circle around a triangle. They will discover that this is possible with all triangles through trial and error and then formal proofs. They will then show me that they can make these constructions themselves. So I start them off with a warm-up. I ask them what it means for a circle to be inscribed in a polygon, what it means for it to be circumscribed about a polygon. That's something that's just vocabulary that they need to know for the lesson. I asked if the following can be true. If you look at the picture, that's a quadrilateral inscribed in a circle, which is part of the standard. And it actually can't be true because for a quadrilateral to be able to be inscribed in a circle, the angles across from each other, so diagonal angles, have to equal 180. They have to be supplementary. So that's not the case, and I'm trying to get the kids to see that. So then question number 4 goes along with question number 3. It's saying, are there some shapes that can't be inscribed in a circle? And obviously there can't be. So I'm asking them to draw 3 or 4 examples of polygons other than quadrilaterals that cannot be inscribed in a circle or circumscribed around a circle. And they shouldn't have triangles for any of them because, as they'll see at the end of the lesson, that's not possible. Like, all triangles can be inscribed in or circumscribed about a circle. So we have a video about how to draw or how to inscribe a circle in a triangle. I'm going to play that.
Triangle, we must first bisect one of the angles. To do this, we're going to take our compass, we're going to pick a different color, I'm going to choose pink, and we're going to draw an arc of any size, doesn't matter, or any length, radius, going through both lines stemming from that point. Now, without changing the length of the radius, we're going to take our center of our compass and we're going to put it on the points where the arc intersects the triangle, and we're going to draw more arcs. Alright, we're going to to do the same thing to the other point. Alright, so now where these two arcs intersect, we're going to draw a line stemming from this point, where it's from the angle through where those two arcs have met. Okay? We're going to do the exact same thing to another point now. Okay? We're going to take our compass and we're going to draw an arc through the triangle so that it intersects with both sides of the triangle, or both sides of the angle. Alright? And we're going to draw arcs. Alright? Same length, radius. Remember, that's very important, okay? And now, once again, where these two arcs intersect, we're going to draw a line. And we want these two lines here, the two blue lines, to intersect. And where those two intersect is the center of the circle that we're going to be drawing. Alright? But we need to find the length of the radius of this circle. Okay, we have the center, but we need the radius. So in order to do this, we're going to take our compass again. Alright, we're going to use different color again. And we want to draw a perpendicular line from the center to one of the sides of the triangle. So we're going to use this side right here. Now we want our radius to be big enough that we're going to intersect the triangle at 2 points, right? If it's not going to work. So this worked, perfect. Now we're going to go and we're going to draw some arcs again, right? Alright, and then once again, we're going to draw a line stemming from this point here where the two arcs intersect to the center of what will be our circle. Oops, that did not work. Let's try it again. Perfect. Alright, so where this line intersected with one of the sides of the triangle, that's going to be the length of our radius. So we're going to take our compass again. Let's change the color. We're going to set the center where we've established the center of our circle to be. And we're going to take the length of the radius and put it where that line intersects the side of the triangle. And now we're just going to draw our circle. And now you can see we have a circle perfectly inscribed in a triangle.
Okay, so as you can see, I inscribed a circle in a triangle. It worked perfectly. The kids find this really cool, and they'll see this and they'll learn how to do it. The next video is circumscribing a circle around a triangle. So it's a little bit different, and we'll watch that now.
To draw a circle circumscribed about a triangle, we first have to construct a perpendicular bisector of one of the sides of the triangle. So to do this, we're going to take our compass. Alright, we're going to put the center on one of the vertices of the triangle. We're going to make it so that the length of our compass, the radius of our arc, circle, whatever, is a little more than half the length of the side of the triangle. And we're going to draw an arc. Alright? Then we're going to go to the other vertex of the triangle, and we're going to draw another arc. We want to connect the two arcs, alright, draw a straight line. Well, it connects the two intersections of the arcs, right? So we're going to do this. Alright? Now we're going to do the exact same thing to a different side of the triangle, alright? Let's change the color. Is this a little bit more than half? It is. So we're going to draw an arc. We're going to do the same thing over here, right? Okay. So now we're going to connect the two intersections of the arc. Alright? And as you can see, these two lines, these two dark blue lines, intersect at a point. Alright, that's going to be the center of our circle. Alright? So now we're going to take our compass. We're going to set the center where those two lines intersect, right? And we're going to make the length of the circle we're about to draw one of the vertices of the triangle. And now we're just going to draw our triangle, our circle, and as you can see, the triangle is perfectly inside of this circle. The circle is perfectly circumscribed about the triangle.
So as you can see, that worked as well. So I'll show both these videos to the students. I'll ask these questions after they watch the videos. Draw for me examples of circles that cannot be inscribed in a triangle. Draw for me on your papers examples of circles that cannot be circumscribed around a triangle. And is this possible, yes or no? Is it possible to draw something like this? This way they can figure it out on their own without me telling them. We're going to prove as a class that all circles can be inscribed in any triangle using this proof here. And we go through that as a class. Here we're going to do the exact same thing with circles, proving that all circles can be circumscribed about a triangle. Then I'm going to give them this ticket out the door. Using a straight edge and compass, inscribe a circle inside the triangle, and using a straight edge and a compass, circumscribe a circle about the triangle. So what we did in the video, but they'll be doing it themselves. And then these are the links I used to find those proofs. And so yes, that's my lesson plan.